Hey everyone, welcome back to the AI Engineering for Flutter developer series. In the first two videos, we covered the fundamentals and how to build more reliable AI features using structured output, streaming, and proper error handling. But here is a big limitation with single AI core. They struggle with complex multi-step tasks, and that's where AI agent comes in, and that's what we'll be doing today. So we'll be going through a simple but powerful multi-agent system in Flutter, specifically a planning agent, a generation agent, and a validation agent as well. And by the end of this video, you understand how to design agentic workflows and implement them in real Flutter application. By the way, if you find this series valuable, please like the video, subscribe, and drop a comment in the comment section. I would love to receive your feedback. And without further ado, let's get started. First things first, let's clarify what an AI agent really is. A regular LLM core, LLM simply means large language model. Core is like asking a smart person one question and getting one answer. Why an AI agent is more like giving someone a goal and letting them think, plan, and take multiple steps to achieve it. So that's the difference between a single LLM call and AI agent. So one just give answer, and the other one think, plan, execute to achieve that particular task that has been assigned to it. So that's what we'll be doing in this video. So we'll be focusing on simple and practical multi-agent pattern, starting with the first one being planning agent, that is break the user request into clear steps, and the second one, generation agent, that is executes the plan. So the plan agent plans, the generation agent executes the plan and creates the output, and the third one is validation agent. It reviews the results and checks for quality. So that's different steps. So we have from planning to generation to validation as well. So this pattern is extremely useful for real application and also for production level application as it is. So we'll be going through different examples, and we'll be already build the project anyways, but we'll be using that particular example project, a simple feature builder. That is, a user will give like an high level request, like for example, build a dark mode on my setting screen or whatsoever, or create a clean Flutter login screen with email and password, validation, and all sorts. Then the system works like the planning agent creates a structured plan, the generation agent turns that plan into actual code or UI description, then the validation agent reviews the output and suggests improvement. And that is what we'll be doing in the example project today. So now let's start by building our planning agent. By the way, the planning agent, again, the goal is that the planning agent plans the output, whatsoever we want to actually build. So the goal is the agent takes a vague user request and turn into a clear structured plan. Now let me just go into the code base so I can just show. So now let me switch to the feature planning. So now inside the folder, by the way, if we go to the GitHub page, the GitHub, I have the branch for this video theory. Now I'll be creating a branch after this video, so you can just go over to this GitHub. The link will be in the description, so you can check it out. So you can switch between the branches, save the implementation for each video, for part 1, part 2, and for this current part as well. So that's that. So now for the planning agent, which actually transforms the user request into a clear and structured plan. Now, so if this is our video theory folder, so inside the agent now we have this planning agent. So inside the planning agent, basically where we actually execute what we want. So now these are planning agents. API key model name, again we are sticking with 3.1 Flash. So now this is a structure. If you follow the video 2 in this particular series, we have to do with streaming structured outputs as well. This is exactly what we talked about. So this is a structured output, and we are trying to tell the AI model to act as a senior Flutter software architecture. So your role, you can reiterate, so your role is to take high-level mobile web request and generate a clean structured architecture. You must respond only with a validation object, the title, the overview, target platform, components to build, implementation step, and risk consideration as well. So this is our structured output that we have given the AI model. So now this is where we execute everything. So now inside our requests, basically the content, the system instruction. So this content basically is what the user type. You can see feature request. This is the user input prompt. Then this system structure, system instruction rather. This is what we give the system instruction. And if you notice as well, we have generation configuration. So we have the response type where we specify application JSON. So this guarantees Gemini return structured JSON that safely deserialize into our that feature plan model without string manipulation act. So if you go to the model now, you see feature plan. This is our feature plan, basically the planning model. So with the JSON that we already set, the response type that we already set as JSON format, it guarantees that there won't be manipulation acts or whatsoever. And also we set the temperature to 0.2. By the way, temperature simply is how predictable AI response can be. So we have between 0. to 0.3. So that is the lowest temperature, and that's like the safest temperature as well. Then we have 0.4 to 0.7. That is like a moderate and standard. So it won't be repetitive and all sorts. But for this particular level, we can set it to 0.2, so it can actually repeat whatsoever that is needed as well. So that is it. So we send the request and we get the response as fast as possible. So that is our planning agent essentially. So a good plan makes everything that come after much more reliable, and as simple as that. So now the next thing now is to go over the generation agent. So this agent takes structured plan and actually produce the output. In our case, Flutter related content or code suggestions. So we'll go over the output as well. So if you go over the generation agent, this is the code, this is the model for the generation, basically the title, explanation, Flutter code, and dependency if there's need to add any dependency. So this is just the model. So now let's go to the integration itself. So let's just go over the system instruction. So you can see inside the system instruction that we ask the agent to act as expert lead Flutter engineer. Your task is to take architectural feature plan and write production ready code claim where formatted Flutter that code. So you must respond only in valid JSON. That the reason why we actually getting the JSON that is so that we can better use it, and it is more easier for the next AI agent to actually read the output as well. So that is one of the reasons. So we just get the title, explanation, the Flutter code, and the dependency if there's any. So that's pretty much it. So generate the code pretty much like what we have in the plan mode. But for this now, since we are moving from the system executes from planning to execution, which is also generation. So that is the first step here. So this two-step now, the generation agent does not start from scratch, as you can see. So it's received the structured output from planning agent. So this is the user prompt. So this is the architecture plan. So this is from you can see this is from the feature plan. So it's received the architecture plan from the planning agent as well. Then we send a request and we make sure that it's in JSON format as well. You can see the temperature here, we set it to 0.3 as well. So it's still within the range of low temperature as well. So we just received the response and we are good to go. So that is our planning agent. So the next is we actually validating, the validation agent as well. So now this agent, the validation agent, acts like a reviewer. It's just like code reviewer, on GitHub now. If you create a PR, someone reviews the code before merging and all sorts. So this agent acts like a reviewer. It checks the output from the generation agent and looks for issues, missing pieces, or areas that can be improved. So that is pretty much what this validation agent is doing. So we are still using the same model. Then our structured outputs as well instruct the system that is act like a lead code auditor and security reviewer for Flutter application. So your goal is to audit generated Flutter code against user request and architecture plan. So all the requirement has been set here. So we must evaluate code quality, completeness, error handling, and so on. Then we set some requirements. Quality score, you can see between 0 to 100 is pass for quality score. Identified issues, improvement suggestion, and refine code snippets if there's any. So now inside the validation, now you can see now we are basically moving from planning to execution to validation as well. So this is our prompt input. Now you can see the original request. So this is the original request. Then we move to architecture plan. So architecture plan, then what's the generation agent actually did. So the output from the generation agent. So this is the output from the planning agent as well, and our original request from the user. So this is the flow. Then we pass it to the agent, and then we're able to generate the response. So it can validate everything right from knowing what the user actually requests for, see what the planning agent, the output of the planning agent, and also seeing the output of the generation agent. Then it can use that to validate, to do the validation check, and we're able to run with that. So again, the validation agent acts like a senior code reviewer. It checks for missing validation, accessibility flaws, and anti-patterns, essentially giving the result a quality score of between 0 to 100. Yeah, so basically that's the whole process. And also having a validation step significantly increases the quality of final results, essentially. So we can put that in place. So now putting everything together, you can see that everything is separated. This is planning, this is generation, this is validation. So how do we join everything together? Connect everything into one single workflow. And that is where we have this our orchestrator agent as well. So now with pipeline orchestrator agent, now we'll be able to move systematically from planning to execution to validation as well. So just going through the code of agent orchestration service, I will show display the app. By the way, I'm already running the app on web. So if you check my terminal, I'm already running the app on web, and this is the app here now that you can see. So we'll soon quickly go through it so we can see how it works. But let's just finish with this. Let me restart the app. Let me move this a little bit. So for the orchestrator service now, basically start a timer. It starts from this is our step one now. So the planning agent. So this is our planning agent. Move from, you can see the plan feature as well. So basically from the plan feature, it starts from step one, which is plan, then move to step two, which is generation, then validation as well. So that is pretty much what is being done here. So the orchestration agent is the one that starts the whole workflow, just like pipeline as well, and connect everything together, so into a live state, and powers the UI as well. So that's pretty much on how the hoster was able to work together. So easy as it gets. So you can see how all the values are being passed from one stage to another here. So now we can go over the code base, the UI, the app itself to see. So now this is just basic default prompts that we can just. So now if I click on this build animated counter now, then I can run the agent, even though the API key is not yet assigned. You can see the planning, architecture agent, generation, Flutter code agent, validation, audit agent as well. So it will run from each pipeline. So this is what we call multi-agent pipeline timeline as well. So with this, we are able to run multiple steps from planning to execution to validation, audit as well. So let's test this out. Let me grab my API key. So to get the API key, head over to Google AI Studio, my same API key that I used throughout, then save. So you can see I start the process. So you can see planning now. Planning is currently going on. So once planning is done, then you can see that this is architecture plan. Okay, validation is currently going on. So okay, so validation is done as well. So let's go over the plan to see what the planning agent was able to generate for us. Remember, this is our prompt: build an animated counter widget with smooth scale easing. So now let's see. So this is our architecture plan. So animated scale counter widget targets iOS, Android, web, and desktop. Usable performance optimized filter widget. Component to build. You can see basically this is like planning the whole stuff. Define the widget, implement twin animation, integrate a value listener, apply curve, add accessibility semantics as well. So architecture edge cases and risks, performance overhead, and all sorts for the planning. So the Flutter code, this is generation. So this is this architecture, this step 1, this step 2. So the Flutter code, basically the title, if you check the model here, just like how we plan it. So sorry, this is the Asian code model. So the title, explanation, Flutter code. So this is the title, this animated scale counter Flutter. This is the explanation here. This explanation uses to animated builder to handle implicit scaling animation and so on. So this is the Flutter code, which is this Flutter code here. So if you scroll, you see like it actually builds like a sample Flutter code. And so the last thing for dependency, you can see that it didn't actually mention any dependency here because this does not require any dependency. But if you, let's say we select another let's say this settings page with toggle, I believe it might likely add a state management package, so it will be listed as well, like the package to install. So this is the Flutter app. Then going over to the audit report as well. So for the audit report, you can see the score. So quality score 85 over 100. So basically what you said inside our validation report. So these are our quality score essentially. So it's passed. That's why we have this check. So if it's not passed, it will be 4 what's it called, red instead. That's between 50 downward as well. So now stage 3, quality and security. So identify issues and fixes. The use of value key, basically all the issues inside the code that was generated here. So that is what this audit actually is giving. Also recommended improvements, use repaint boundary, and also you can see the recommended code refinement patch. So it already generates like a patch for that particular error that it noticed. So that's pretty much on the whole structure of the AI agent. I mean, using AI agent to actually do multi-step tasks instead of a single call. So let me know what you think. Again, that is all on agents. How this is useful to your a production grade Flutter app is basically like you able to build AI features that execute a plan, also plan accurately, execute, then validate what has been generated. So it won't just generate blindly and assume everything is okay. So it's good to first of all plan, execute, then validate the output. So that is like several step validation before actually giving it out to users or whatsoever. So that's pretty much. Now let's just go over like a quick summary of what we covered in today's video. So the first thing is AI agent allows us to handle multi-step tasks much better than single LLM calls. So that is what you can see here. You can see with AI agents now we're able to go from planning to generation to validation. The next point is the planning, generation, and validation pattern provide clear separation of concern. So we can easily like track if we want to improve the planning output. Now we can easily just improve this system prompt or whatever that we want to improve here. So it's valid, it provides like clear separation of concern. That's pretty much. And the next point is structured output, especially in JSON mode. So that's the best way for AI agent to communicate reliably. So structured output allows AI agent to communicate reliably. And the fourth point being that keeping the architecture clean makes the system maintainable. As you can see, we make the system clean, and for all the agent essentially. So it makes the whole system maintainable as it were. So with this now, we can easily like move from one step from another, improving on it as required. So that's pretty much on the summary of this whole part 3 of AI engineering for Flutter developer. I hope you have gained one or two stuff. And by the way, before we go, I've updated the AI engineering. If we go over the what's it called, the starter pack, so I've updated it with the multi-agent code and pattern from this particular video, so it will be updated. So by the time you're watching this video and you're clicking on the link for this in the link in the description or in the comments, you'll be able to download the starter kit. So in the next video now, which is the final video of this series, so it's just 4 videos for this series, so we'll focus on production AI engineering, that is, we'll cover performance, privacy, security, evaluation, and best practices for shipping AI features in Flutter app. So that's pretty much on this series. So I would love to see you in the last video. And by the way, if you find this series valuable, please press the like button, like the video, subscribe to the channel, and drop a comment. Support this community as I grow as well. And as well, my Discord channel is in the description, so make sure to just click the link and join the Discord server so you can better have be part of the community essentially. So thank you for watching, and I will see you in the final video of this series. Take care for now. Bye.